When we take a step forward and move on to our trajectories, this is an example of an opposition class on the left, or a short stay mission, and a conjunction mission on the right, which is long stay. I'll draw your attention to the two boxes there. You can see the outbound durations are about the same. The surface stays are drastically different, and the return is about 50% less for the long stay mission. So our analysis says we have a significant logistics strain to support a 500-day surface mission. We've done that analysis. We've tried to do the cost associated with that. We also then look at what the logistics strain is for a 30-day mission with the longer returns. So we're balancing trades. We determined that for our initial reference that you saw on the previous chart, that we felt like a 30-day was something that was more supportable than the 500 surface day stay. Now, it's up to us to show our work. Our deputy administrator has challenged us from the day she came on the job that we need to show our work so that people understand how we arrived at these conclusions. You'll see in the coming months some very short white papers to describe some of the parameters I just described to you here, to show our work for further understanding and feedback that others may have after you look at the objectives, after you take a look at some of the reference architectures that we've put together. So as we move forward from these reference architectures onto our next steps, we take a look at how the moon and Mars are connected. Spuds showed you a version of this chart from before, but our connectivity in defining our architecture is making sure that we get the time on our systems on the lunar surface, understanding how they're connected to what we want to do on Mars. That also applies to what we're doing in lunar orbit on Gateway. So we need to understand that connectivity. We need to understand the total time we want on these systems before we say we're ready to go on to do those demonstration missions to Mars. And as we move on from the connection between the lunar surface and Mars, I'll show you an example of a graphical result of our strategic analysis cycle, a representative. As you saw in those cycles, we have a lot of assumptions, a lot of inputs. They drive a great deal of timing. They drive a great deal of content. So as you look at this chart from left to right, you can see our progression from low Earth orbit to the lunar return to potential Mars missions. Again, this is not our blueprint. This is one of the outputs. So we understand how the system fits together and how we can then plan our budget. Ultimately, we need to tie our budget to what our architecture is so that we can say to all of our stakeholders, this is when we want to go, and this is what we believe the cost to be. So you can see the progression of the rows with crew. First, where we're in LEO today, operating the incredible International Space Station, moving on to Gateway and lunar surface missions, and then the increase in crew number and also duration on the surface, and then the elements we need to make that happen. You can see the cislunar as we grow there with first starting with our comms, going on to our gateway elements, building up that capability, and then supporting it logistically with things such as the HTV. On the surface, you can see us growing from our initial Artemis 3 landing, growing with our LTV, moving on eventually to a pressurized lander, and then the cargo landers that support us for those longer stays on the lunar surface. We, of course, work closely with our other mission directorate partners in space technology and science. I said our support is to science, but we use the technology being developed in STMD to help enable our missions as well. And then on the Mars line, we are completely tied to understanding what's being done today on Mars with SMD. And then you can see as we start to build up for our Mars missions that even the logistics just for a 30-day mission start much earlier.